Okay, so let's go ahead and start talking about section 1.6. Section 1.6 deals with a set of complex numbers. What are complex numbers? We know that if we're asked to find, say, the square root of negative 4, so like if you're asked to do the square root of negative 4, you probably instinctively know that we typically would say that that's not real. Why do we say that's not real? Well, this is asking me to find a number that I can multiply by itself to give me a negative value. The issue here is that if you multiply a number by itself, whether it's a positive number or a negative number, in either scenario, you're multiplying either two positives together or two negatives together. And in both of those cases, you're going to get a positive answer. So it is not possible to multiply a number by itself to give you a negative value. So we know that this has no solution, or we just say that it's not real. The set of imaginary numbers were created to handle situations like this. So we think of the set of real numbers as incomplete because they do not include these types of problems. And the set of imaginary numbers were designed to fix this situation. Whenever you see the lowercase letter I, it's always going to be understood to mean the imaginary number I, which is defined to be the square root of negative 1. So we can say that I equals the square root of negative 1, or we can also say that I squared equals negative 1. These are just two different ways to say the same thing. When we work with complex numbers, complex numbers include the real numbers, which you're used to working with, as well as the imaginary numbers. So if we take the real numbers and the imaginary numbers and just imagine putting those two sets together, then that creates the set of that creates the set of complex numbers. So again, complex numbers just simply comprise of real numbers, which you're used to already, in addition to the imaginary numbers that we're learning here. Complex numbers are always going to be written in what we call the standard form. So the standard form for a complex number is going to be this a plus bi, where a is the real part of the number and b is the imaginary part. So whatever you're multiplying to the I is your imaginary part. All right, so we are ready to go ahead and start looking at some examples. Okay, so for example 1, we're asked to perform the indicated operations with the complex numbers. Part A, we've got 2i times 3 plus I. So we can go ahead and distribute our 2i. 2i times 3 gives me 6i. 2i times I gives me 2i squared. All right. Now, what do we know about I squared? As we said earlier, the definition of a complex number, I equals the square root of negative 1, or it's also true that I squared equals negative 1. So anytime you're doing a problem like this and you encounter I squared, go ahead and substitute it with a negative 1. So you're going to say this is 6i plus 2 times negative 1, and that can be simplified as 6i minus 2. So our answer is 6i minus 2. All right. Is this technically a plus bi form? Well, not quite. We're going to be asked to specifically write these in the a plus bi form. So let's go ahead and say that we'll rearrange this. This is going to be negative 2 plus 6i. So writing it in a plus bi form, we see that a is negative 2, so that's the real part, and our imaginary part is our b, which is 6. For part b, we're multiplying 5 minus 2i times 5 plus 2i. All right, you may recognize these as conjugates. We've talked about conjugates already. Remember, conjugates have the exact same terms inside each binomial. The only difference is that the middle signs are opposite. So we're going to go ahead and FOIL this because these are binomials. 5 times 5 is 25. Doing my outer terms, 5 times positive 2i gives me plus 10i. Multiplying inside, negative 2i times 5 is going to be minus 10i. And then I multiply my last negative 2i times positive 2i is going to be minus 4i squared. All right? And then combining like terms, 25, and then the 10i's cancel each other out, just give us 0. And over here we've got minus 4i squared. Again, we know that we can replace I squared with negative 1. So we've got 25 minus 4 times negative 1. So we have 25 plus 4, or our answer is going to be 29. Okay. Now, did you notice how all of the i's ended up canceling one another out in this problem? That should not be a surprise because, again, these were conjugates. And just like we saw with the conjugates when we were working with radicals, they always cancel each other out. So if you start a problem dealing with conjugates that's working with these imaginary numbers, if you're multiplying two conjugates together, those i's can all end up going away and just leave you with a nice whole number for your answer, or some type of real number for your answer. If for example 2, we are asked to find the product of the given complex number and its conjugate. So for part A, we've got 3 minus I. What is the conjugate of 3 minus I? Well, again, keep the two terms the same, but change the middle sign. So we're going to multiply this by 3 plus I. So we're going to say parentheses 3 minus I times parentheses 3 plus I. And then we can FOIL this. That's going to give me 9 plus 3I minus 3I minus I squared. Okay, again, with these being conjugates, we are not surprised to see these middle terms canceling each other out. So we've got 9 minus I squared. And again, we know that the I squared is the same as negative 1, so we can make that substitution. And we get 9 plus 1 for 10. For part B, what is the complex conjugate of negative I? Well, that's the same thing as 0 minus I. Complex conjugate of 0 minus I should be 0 plus I. So we're going to multiply this by just positive I. So we'll have negative I times positive I gives me negative I squared. And again, replace I squared with negative 1. So negative, put in parentheses, negative 1. So you've got this double negative, so your answer is positive 1. So for example 3, we are asked to write each quotient in the form A plus BI. So again, we're asked to write this in the standard form for a complex number. Of course, this is not in the A plus BI form because this is a big fraction. And with us having two separate terms in the denominator, we cannot just manipulate this using basic arithmetic to get it in the form that we need it in. To get this to where we need it to be, let's think about what would happen. This is very similar to when you were asked to rationalize the denominator if you have more than one term in the denominator. If you recall, that was in section, I believe that was a section B3, which we did with B2, so that would have been in the very first video lecture that we did. But just like when we had to rationalize a denominator involving more than one term, we're going to use the conjugate of the denominator. So let's multiply the top and the bottom of the fraction by the conjugate of the denominator. And again, we do the top and the bottom, so we make sure we keep an equivalent fraction. We have to make sure that we do not change the value of what we were given at the beginning. So if we multiply the top and the bottom by the conjugate of our denominator, let's multiply the top and the bottom of this by, and you should know what the conjugate is. Multiply the top and the bottom by, the conjugate here would be 2 minus I. We need parentheses around each binomial because we will be foiling these. So foiling the top, I'm going to go ahead and ask you to pause the video here. Foil the top, foil the bottom, simplify as far as you possibly can, and then see if you can figure out how to get this into the A plus BI form. And then we'll complete the problem in a moment. Okay, so do you think you know what to do? Let's go ahead and see what happens. In the top, I'm going to multiply or FOIL 8 times 2, so that's going to give me 16 minus 8i minus 2i plus I squared. My denominator, I'll have 4 minus 2i plus 2i minus I squared. In the numerator, I can combine negative 8i and negative 2i, so that gives me 16 minus 10i plus I squared. My denominator, I'll have 4, the 2 i's cancel out, and then it leaves me with minus I squared. Hopefully you remembered that you can replace I squared with negative 1. So that gives us 16 minus 10I, and that's going to become minus 1 over 4 minus parentheses negative 1. Now in the top we have 16 minus 1, so combining like terms, that's going to be 15 minus 10I. So we've got 15 minus 10I in the top. In the denominator we have 4 plus 1, which is 5. Okay, maybe you got this far and weren't sure how to proceed from here. Because you've now just got a single number in your denominator, now you are allowed to break this apart into 2 separate fractions. So 15 minus 10I all over 5 is the same thing as 15 over 5 minus 10I over 5. Okay, you could not have done this back when you had 2 separate terms in the denominator, but now with it just being a 5, it's okay. So that gives us 3 minus 10 over 5 is 2. 3 minus 2I is our answer. Is that in the correct form? Yes. It needs to be A plus BI. So we've got 3 is A, so 3 would be our real part. Negative 2 is B, so negative 2 is our imaginary part. So our answer is 3 minus 2I. For part B, in order to get this one into the correct form, we can do the same concept, multiply the top and the bottom by the conjugate of the denominator. The conjugate of I is negative I. So we can multiply the top and the bottom by negative I right from the start. All right. We'll need to distribute in the top, so we'll have negative 3I plus 2I squared over negative I squared. All right, and then in the top we can go ahead and substitute negative 1 for the I squared, so you've got negative 3I minus 2 over negative parentheses negative 1. So negative 3I minus 2 over positive 1. And of course, if I simplify that, that's just negative 3I minus 2. Is that in the A plus BI form? Not quite. They want us to have the real part first and the imaginary part in the back. So let's rewrite this as negative 2 minus 3I. Okay, so now A is negative 2, so our real part's negative 2, our imaginary part is negative 3. And that's our answer. In the very beginning of the problem, you may have been wondering if you could just break this apart, because we really did not have a binomial in this denominator. We just had I. So you could have broken it apart as 3 over I minus 2I over I. Your steps would have looked a little bit different, but you still should have arrived at the same answer that way. So let's talk about what happens when we're working with square roots of negative numbers. If you've got the square root of, say, negative 3, all right? Well, we know that this is the same thing as the square root of negative 1 times 3. And we know that we can break this apart into 2 separate radicals. So the square root of negative 1 times the square root of 3. That's using a property from an earlier video lecture. Once we have the square root of negative 1, we can go ahead and make the substitution where this is going to be I. So we get I times the square root of 3. So this allows us to go a little bit further with these types of problems. Let's take a look at example 4, part A. So square root negative 8 plus square root negative 18. What can we do? Well, first we see we've got these negatives inside these square roots. So we know we can go ahead and rewrite this by taking the square root of negative 1. So the negative on the inside of the square root is the same thing as putting an I on the outside of the square root. And then you just have a positive number inside to work with. So we've got I square root 8 plus I square root 18. From here, it's very similar to problems that we've done before. 8 can be written as the square root of 8 can be written as the square root of 4 times 2. Why would I choose to write 4 times 2? Well, I know that 4 is the perfect square, and I'll be able to take the square root of 4 easily. Square root of 18 can be written as the square root of 9 times 2. So now I can break this apart even further. I'll have the square root of 4 is 2, so I can say 2i on the outside of my radical, and this 2 stays inside. That 2 is not a perfect square. Over here, the square root of 9 is 3, so I can remove it and have 3i times the square root of 2. All right, now, anytime you do a problem like this, it's important to ask yourself if you're left with like terms. Is 2i square root 2 a like term with 3i square root 2? The answer is yes. The only thing that's different between these two terms is the number in the front, which we call the numerical coefficient. The I is exactly the same. They're both a square root as opposed to a cube root or some other index. And they both have the exact same thing on the inside of the radical. So they are like terms, and they can be combined. So if you combine 2 and 3, you get positive 5. So our answer is 5i times the square root of 2. For part B, what can I do here? Well, I see I've got a negative inside my square root, so I'm going to remove I first. All right. 50 inside the square root. Is there a way that I can write 50 so it's easier for me to work with? I know that 50 is equal to, you can take a moment to think about that. You can pause this for a second if you want to figure it out. I know that 50 is the same thing as 25 times 2, and I know that 25 is a perfect square. So I've got negative 4 plus I square root 25 times 2 over 4. So the square root of 25 is going to give me 5, so I can bring 5 out of the radical. So I've got negative 4 plus 5 times I times the square root of 2 all over 4. Okay? In some situations, it would be okay to leave your answer like this. For sometimes if you're working with maybe the quadratic formula, which we haven't talked about yet, but you probably remember that. Sometimes it's okay to leave the answer this way. It depends on the directions. We were specifically asked to write our answer in A plus BI form. That means that we have to have two distinct terms. We cannot have a big fraction bar. So we do need to break this apart. So we can say that we have negative 4 over 4 plus 5i square root 2 over 4. All right, well, negative 4 over 4 can reduce to negative 1. And then over here, we can write this as 5 square root 2 over 4 times I. So you might ask, why did I move the I after the square root? Well, because I have to be very clear about where the real part is and where the imaginary part is. A is negative 1, that's the real part. My imaginary part is the coefficient on I, the 5 square root 2 over 4. So that's my answer in the correct A plus BI form.